Gas laws. So there's two gas laws we're going to look at that we can use to find the amount in mole of a gas when we've got its volume, essentially. One is the molar volume. So Avogadro, in addition to making Avogadro's number, also looked at gases, and he found that if you have equal volumes of any gas, they contain the same number of molecules, as long as they're under the same condition of temperature and pressure. So if you've got a mole of a gas, it will occupy the same volume as a mole of any other gas. So a mole of carbon dioxide, a mole of oxygen, a mole of nitrogen would all take up the same volume as long as we keep the temperature and the pressure the same. Okay? We call the volume of 1 mole of gas the molar volume, and if we've got standard lab conditions, which are defined as a pressure of 100 kilopascals and a temperature of 25 degrees Celsius, then our molar volume is 24.8 litres. Okay? And most gases are pretty close to that. Okay, so if we look at a few of them, we would see that, oxygen 24.9, nitrogen 24.7. So it's a slight approximation, but it's pretty close. Now, to use molar volume, this is one of the nice simplest ones you're ever going to use. Amount in mole is the volume divided by the molar volume. Okay, and our molar volume is going to be 24.8. So if we've got 2 litres of hydrogen gas, and it's at 100 kilopascals and 25 degrees C, which is our SLC, then we do 2 divided by 24.8 volume divided by the molar volume, and that gives us our amount in mole. And I'm putting that to 2 sig figs because my 2 litres and my 25 degrees are both to 2 sig figs. The second law we can use is if it doesn't have to happen to be at standard lab conditions. So if the temperature's higher or lower or the pressure's different, then we have to use this slightly more complex equation. So if you can use mole of gas, use that one. But if you can't, then you use this one. This one's called the ideal gas equation. PV equals nRT. Pressure times volume is the number of moles times the gas constant times the temperature. Okay? And real gases get pretty close to obeying this, so if you actually do the calculation, you're going to get pretty close to the right volume. Okay? The gas constant, that's a constant. It's always 8.31. Decimeter cubed to K for Kelvin. That's a way of measuring temperature. So mole to the -1. Okay? That number is in your data book. So you don't need to memorize it. It is in your data book. Use it and check it. So if we want to use this, there's a couple of things we've got to do. Right. The first thing is we've got to know the temperature in Kelvin. Now, Kelvin is on the same linear scale as Celsius, but it's 273 more. So a temperature of 0 degrees Celsius is 273 Kelvin. Okay? 18 degrees Celsius would give us 291 Kelvin. Okay? So if I wanted to know the amount in mole that was doing a volume of 26 litres, a pressure of 104.2 kilopascals, and a temperature of 18 degrees C, or 291 Kelvin, then this is the equation that I would use. So I would times the pressure by the volume, that gives me the amount in mole, which is our unknown, times our gas constant, 8.31, times our temperature in Kelvin. Rearrange that slightly to find my mole, and that will give me 1.12 mole, which I'm realising now should be 1.1 because it should be to 2 sig fig because that volume up there is to 2 sig figs.